Hello, hello, hello. Today is day 2 of doing something new on Lead GPU. Uh, Today we will be looking into ReLU. What exactly is ReLU? It is rectified linear unit, which is essentially activation function. Now, what we will be doing is we will be explaining how this can be solved on a GPU. What happens if you increase or decrease threads per block on a GPU? What are the performance implications of that? So let's get started with the question. Implement a program that performs the rectified linear unit ReLU activation function on a vector of 32-bit floating point numbers. The ReLU function sets all negative values to 0 and leaves positive values unchanged. Basically, ReLU is an activation function which does max of 0 and x, which is essentially the value. What are the implementation requirements? External libraries are not permitted. Cool. We already have been given this CUDA runtime included. The solve function signature must remain unchanged. What's the signature? Input output pointers, which are of type float, and an, which is the size of input. And we need to return the output. The final result must be stored in output. Makes sense. Example 1, input -2, -1, 0, 1, 2. Everything negative have been uplifted max to 0. Everything positive or 0 remains as is. Constraints and can be up to 10 to the power 8. Sounds good. How do we solve this? So first of all, let's look into the solve function. We have threads per block 256 and then blocks per grid. As I explained briefly in my previous video, there is a concept of grid, then blocks, and then thread. Grids contain blocks, blocks contains thread. That's how GPUs are internally. So now what do? We have this ReLU kernel that we need to write code in. We are passing blocks per grid, threads per block, and input, output, and n in there. Then we do CUDA device synchronize. Makes sense. So what is exactly is threads per block? So I mean, this choosing this number of threads per block is basically about giving the GPU enough work to stay busy in simple terms. And GPUs usually need a crowd of tasks to run efficiently. The number of threads per block is basically that crowd size. Too few threads, and if the crowd is small and the GPU runs out of things to do, then when some tasks are waiting for data, it will leave other parts of the chip idle, right? And what exactly is an optimal number of full crowd? What happens when we have a full crowd? It ensures that whenever some threads are waiting, others are ready to start immediately. And what will happen if that happens? It will keep the GPU cores working continuously and it will help maximize the performance, right? Now let's say what will happen if, for let's say we have 16 versus 32 threads per block. Using 32 blocks, 32 threads per block is basically almost always significantly better than using 16 because GPU process threads in a group of 32 and it's called warps. So 16 threads per block results in inefficient use of hardware because a full 32 thread warp is still allocated, but only half the threads are active. And what will happen if that happens? It will waste a lot of computational resource. So 32 threads per block fully utilizes one warp, meaning all threads in that group are active and working, leading to much greater efficiency and speed. So for optimal performance, what we usually do is that we generally want thread block size that are multiples of 32. Example like 32, 64, 128, 512, and so on, which will help ensure no threads in a warp sits idle. Coming back to our code. So as last time we saw that, first we need to get the thread ID or the index this particular thread, which is executing this kernel will, operate at. So how do we get? Index is basically, hey, which block are we at? So block ID X, and then multiplied by what's the dimension of this block. So it's like basically multiplied by block dimension, and then basically we add this by thread ID, and then we know that this is the index, this is being looked at by this particular thread. Now always remember there can be more threads than what the input and output size is, so we always need to check for this edge case that hey, n idx should always be less than equal to n. If it is not written, remember that we are not returning the output, we are the function signature returns a void, so we just need to return, and we are just writing into the float floating pointer, not the floating pointer but the pointer which points to a float input array, right? So what we do, we just basically set output idx equal to what we do, we have to do a max. And since this is floating, we do a max using fmaxf, which is designed to take in float numbers. Now we do fmaxf of what? 0, obviously, and we can write it as 0.0 because this is float. And then we do input of idx. That's what we need to do. Ideally this should work. Let me check my code. We are getting the right index, block idx.x times block dim.x added by thread id.x. If idx less than equal to n, it should be greater than equal to n. idx greater than equal to n, then return, and then output idx is yeah, makes sense. Let me try to run this. Hopefully this should work. Yeah, that's it for today. Hope you liked it. If you're watching this on X, follow me. If you're watching this on YouTube, subscribe. See you soon.